In this video, I'm going to walk you through how to do your tide charts lab for Chapter 6. It will be a bit of a long video, so in the description I will put time markers so that you can jump to the spot that you need to go to. I have my lab open, and you can see that the directions are here, and we're going to just follow this through to the end. So let's start off by opening up our saltwater tides. What we're going to do in this lab is we're going to take some predictions for tides, and then we're going to build a sine and cosine curve that will model those data pieces and then extend on continuously forever that we could use to make predictions about what will happen in the future. We're going to pick a state. I have noticed that the West Coast states tend to fit the model nicer than the West Coast states, but you pick whatever one you want. I am going to go to New Jersey, and I'm going to pick the New Jersey-New York boundary area. And let's see, I'm going to just pick a place here. I moved from Poughkeepsie, so I'm going to pick Poughkeepsie. And then I'm going to scroll way down, way down to the bottom. And I'm going to pick a month that I want to model. Let's see, I'm going to go ahead and pick February 2021, and then pick a day that you want to start the tides. It really doesn't matter what day that is, so I'll go ahead and pick the 1st, but we need to have 3 days worth of tides, and we need to have 2 high tides and 2 low tides for each day. So when I hit get tides, that's the first thing I'm going to check. 1, 2, 1, 2. Okay, so I have 2 high tides and 2 low tides for each day. Every once in a while there's one missing, so you'll need to back up. Okay, so I have some data here that I don't really need, like the sunrise, sunset, moon time, if it was a rise or a set, and the visibility. I'm going to copy all of this fun stuff, and then I am going to come over to my Word document. I'll make it a little bit bigger. And I'm going to post that data in here. Now, I don't need all of it. And first of all, it's a little smush, so I'm going to extend this so I can see everything. And I'm going to get rid of this. Now, it's not set up quite like a table, so you can't just highlight it all, right, because you'll get rid of that. So you have to go row by row, unfortunately, and delete those piece by piece. Oops, too much. Control Z. And then after you have that cleaned up, although you might want to save that data for later on if you maybe want to copy and paste it. Like, I'm going to scroll real fast to the bottom of the document, and you might want to just kind of shove it right there in case you either accidentally delete too much, or you might want to know about this moon visibility stuff later. Come back up, and I don't need it to be so big now, so I'm going to squeeze this back together. Oops, too much squeeze. And I'm going to delete this so it fits on one page. And so now I have everything almost that I need. Now I need to change these to military times. And if you haven't worked with military time, you can hit Control when you have your pointer on this link and open that up. And this will convert the military time for you. So for example, one of our times was 9:55 p.m. So I can say the 12-hour time, 9:55, and put in the p.m., and it will do it for you. Or really, all you need to do to convert to military is the midnight hour is 0, then you start counting from 1s. Noon stays 12, but then 1 o'clock is 13, 14, 15, 16, and so on. So I'm going to come back over here. And I think probably the easiest thing to do is just to kind of stick the military time next to it. So 2:50, the AMs will not be a problem. They can kind of just stay as they are. So that's going to be 02:57. That's going to be 09:20. But then the PMs, you basically have to add 12 to them. So instead of saying 3, I need to say 15:03, and 9 plus 12 is 21. I'm going to finish these up real quick. Okay, so now we have all of these in military time, which is almost where we need to be. Military time is fine, but we don't want to talk about the actual minute. We want to talk about everything in hours. So right now we have two measurements, hours and minutes. We need to just talk about hours. So instead of saying 11:11, I need to say 11 point how many hours. So how do you find out what percent of the hour was used up by those minutes? Well, if you're comfortable with the switch, you can just kind of eyeball it, or you can just take your minutes and divide by 60, and then you'll get the portion of the hour. So I can say 11 hours and 11 minutes, or I can say 11.18 hours. I am going to make this a little bit smaller so I can have both pages on the screen at the same time. It just makes it a little bit easier to swap this time over. On top of switching the time over, I'm going to need to not think about 3 individual days, but also think about it as time from when I first started counting. So this first number is 2 and almost, so that would be like 295 hours since I started keeping track of the tides. And then this would be about 9.33 hours since I started. 15, that'd be 05, and then 21.9, I would say 95, but the next one starts right back at 3, and it's not 3 hours since I started counting, it's 3 hours on that next day. 24 hours have already gone by. So for my second days, which for me is a Tuesday, for that second group, I'm going to have to add 24 to this on top of changing the minutes. So not 3, but 27, because 3 plus 24, and then 48 would be a 0.8. Not 10, but 10 plus 24, so 34, and that would be about a 0.15. Not 15, but 15 plus 24, so 39. And 56 is real close, I'll say 95 again. And then finally, 22 plus 24 is 46, and 41 is about 6-7 of an hour. And now I'm on day 3, so it's not 24 hours anymore, right? This is the time that it's been, so this is 24 hours, this is plus another 24, so now 48 hours have gone by. So for day 3, I'm going to need to add 48 to that first part and change the minutes at the end. So 4 plus 48 is 52, and 41 is about 6-7. And then I'm going to add 48 to all of these numbers and swap the extension real quick. My times are switched over not only to military, but from 0 over, and I've changed all my minutes over to what portion of the hour that represents. So now I just need to put in my tide heights. Don't worry about the negatives. You can have negative tide heights. And I think we're going to get a pretty nice model on this one, because you see how the numbers seem to be following a pretty nice pattern. And when that happens, you get a pretty nice model. Okay, now we have everything in the way we need it. I'm going to make this a little bit bigger, so we're just looking at the second page. And now I want to find my cosine model by hand. So I'm going to follow the list. You can jump around, but I'm just going to go in the order that it has here. And I'm going to start with the vertical shift. To find the vertical shift, you need to find your maximum value in your y's, which looks like a 3.3, and your minimum value. Add those two together. Looks like my minimum is a negative 0.1. And then divide by 2. So I have a 3.3 minus a 0.1, divide by 2, and that gives me a 1.6. Now I need to find my amplitude, which is almost the same exact thing, but I'm going to find the difference between these two. So minus the negative is plus, and then divide by 2. These two tend to be pretty close together. Next, we're going to find the frequency. Now, the period, how long does it take to complete one cycle? For a tide cycle is half of a lunar day, which is going to be 12 hours and 24 minutes, so 12.4 hours. But what we want is the frequency, and the frequency is from 0 to 2 pi, how many times does this process repeat? So I'm going to need to take 2 pi and divide that by 12.4. Now, you can leave it as 2 pi over 12.4. I don't really like having the decimal in the fraction, so I'm going to come over here and say 2 divided by 12.4. I'm going to leave the pi out of it because it's easier if these things are in terms of pi. And I'm going to change it to a decimal, but when I change it back to a fraction, it's going to like unsimplify it for me and say math, enter, enter, and I get 5 over 31. So this is going to be 5 pi over 31. Last is the horizontal shift. There's a couple of different ways that you can do this when you're modeling data. What we're going to do is use our first high tide. And my first high tide, if I go back to my data, is at 2:57 a.m., which I think I used 2.95. And that's C. 2.95. Okay, so now I can just go ahead and write my cosine, which is going to be my A value, which is a 1.7 times cos, open parentheses, 5 pi over 31, and then in parentheses I have x minus my translation, which is a 295, and close that up, and then plus the vertical shift of a 1.6. All right. Third of the way done. Now it's time to do our sine function, but we're going to use the calculator for that. I'm going to scroll back up so I can get my data, and I'm pull up my calculator and go to stat and then enter. And I have list 1 and list 2. I'm going to put my time in for L1 and my tide in for L2. Okay, so now all of my data is in. I'm going to scroll back down. And I'm going to run sine reg, which if I go back to the main screen by hitting second mode, I'll clear this screen off and hit stat, calc, and I'm going to go down to sine reg. Now, if you run your sine reg function and it comes back with an error, we're going to need to put L1, L2, 12.4 in afterwards. But let's see what happens first. Does not like it, so let's go 2 and put in second 1 to put the L1, comma, second 2 to put L2, comma, 12.4. Sometimes it does it without a problem, and sometimes it's a problem. And we'll get our sine function in a moment. And they will probably look pretty close. I'm going to make this a little bit smaller so that I can type this in. A is 1 point. I'm going to go 2 decimal places. Say 77. Sine. Now notice that this is not in parentheses, so this is just going to be bx plus c, not b parenthesis x plus c. B is 0.51x. C is positive 0.11. Close that up. Plus 1.43. Okay. Now I have all of my functions. I'm going to use Desmos to plot the original data and graph my cos and sine curve. You can use Excel if you want. I think Excel is a bit of a pain, so I'm going to use Desmos. Put the cursor on that and hit Control and then Enter, and Desmos will open up. There we go. Let's see. I have some stuff in here. I'm going to clear that out so we can start from scratch. Make this a little bit smaller, this as well, so I can see all the things I need to put in there. So I'm going to pull up my data first, go up to the plus sign, and then say table, and I'm going to have to use tabs. So 295, tab over, 3.1, tab for the next row. I'm going to repeat this process. Okay, so now all of that data is in. I'll make it bigger for a second. You can see it popping up on the screen. I'm going to scroll out and then click and drag this over. Ooh, it looks good already. All right, so now what I want to do is pop on our model. So I'm going to scroll down, make this a little bit smaller so that I can get our curves. First I'm going to put in the cos. Right there I'm going to say y equals 1.7, and you can see it popping up already, and I start typing cos and it just knows right away what to do. Parenthesis 5 pi over 31. I'm going to push that out to the side, and actually I'm going to come in here and say an extra set of parentheses, and then x minus 2.95. You see it loading as we type it. Close the x minus 295, close the trig function, plus 1.6. Oh my goodness, what a beautiful curve. Let's do sine now. Y equals 1.77 sine, open parentheses, 0.51 x minus, no, plus 0.11 plus 143. Now it looks really small right now. I'm going to make it bigger by zooming back in. And you can see what a nice fit that is. If you want to look at one at a time, just click on the color dots, so that will turn it on and off. So now I'm just looking at cos. Now I'm just looking at the data. Now I have the sine, right? So you can turn these on and off, and then you can see how they overlap. And now we have clearly two different functions, right? Cos and a sine, but they look awfully close together. Now I want to see all of your data, and this is the easiest way to do it. Come up to the share button, say share graph, and it's going to load. Hit copy, and then come back to your document and just scoot that link right up in there. And now you're going to say which model fits better. This is just what you think. We're not running any kind of regression models to see correlations or anything like that. What's similar? What's different? Both in its shape, but also if you look inside here, what's the same and what's different? Why do you think that is? What caused that? We know a number of things affect tides. Moon phases are one of those. But there's other things as well, and you can look at some of those things at this link. What do you think the limitations of using the sinusoidal model would be? What else can you model with a sine or a cosine function? I'm going to erase my data here. And then after you type all of that up, all you're going to do is come back to the OpenLMS, click on the tide chart submission link. After you save this, upload it and submit it. And that's how you do your tide charts lab.